This is Damian McNamara, and I'm at the Miami Children's Hospital postgraduate course, where a presentation was just given for pediatricians with an update on proteomics and genomics and what's going on in this exciting area where clinicians and researchers are working together to tailor medicines and therapies to specific patients.
Yeah, so we have built a very large-scale biobank at Children's Hospital, and we are working now actively in approximately 40 to 50 different disease areas, and three of the most advanced ones where we have identified a subset of patients who have genetic mutations and subsequently identified therapy that has actually been developed for a different disorder and be able to reposition that therapy into this new area. The examples of those are neuroblastoma, which is one of the most common pediatric cancer among the sort of the solid tumors. It's the most lethal and most severe. Now, the two other examples that I wanted to mention is attention deficit hyperactivity disorder. There we have found that there are certain signaling networks of genes in the brain that have to do with sort of transmitting the signals between the brain cells. They have structural variations, and what that means is that there's sometimes, just by chance, that there's a copy of a whole gene that gets removed or deleted when the genome is being replicated when a baby is being born. And these mutations, they sometimes are inherited from the parents, but sometimes they just happen, and we call them de novo. And if they are present, the sort of the signaling pathway that deals with these mediators is reduced by about 50%. And we believe that this may cause ADHD in about 15 to 20% of children.
And the interesting thing is that you find the pathway, you find the genetic mutation, and then you go looking for existing medications that might address it, right?
And now we have found the medication which is sort of spot on, works to basically amplify the protein which is made by this particular pathway. So we believe that we now will have a very effective therapy which is not going to work for everybody, but it's going to work for maybe 10, 15, 20% of patients with ADHD, but may work very effectively for them and actually restore what they are missing and could almost cure them in that setting. What is also very interesting is that not only do we show that these copy number mutations are present in ADHD, they're also present in autism patients, and they're also present in schizophrenia patients. So we are now starting to phenotype patients based on molecular genetic findings, and it probably makes no difference whether the patient has autism or ADHD. If he has one of the gene being knocked out and the pathway is disrupted and reduced, he or she will very likely respond to therapy that restores it, independent of whether that's ADHD or schizophrenia or autism. I think this is sort of the biggest message or concept that we have today, and sort of the one that we can really do something about right now.